Okay, welcome back, students. Here we go. Now we're doing this one here, 22.3, using a calculator. Okay, let's jump straight in. So, let's bring it over to pen. Oh, it's a bit messy here now. What's happened? Yeah, I was messing with the camera at the end of the last one, didn't I? I had to kind of make my own cameo appearance. Anyway, here we go. Using a calculator to find ratios and angles. Okay, we'll figure out what that means as we go along. Okay, so let's jump straight in. Here we are. And this time, guys, I have the answers here that we can check. Okay, so I'm putting this on pen and paper and not straight in here because I just want to show you the process again. So we will write that the sine, which is a function, just want to give you a little bit of background here now. The sine it goes up like this. This is what the function looks like. If you've got your angle going out here, and you got your sine of angle going up here, or your y-axis going up here, your function up here, it curves up along like this. Okay, in 90 degrees, and then it stops. Now it actually goes on if we do leaving cert maths, and it continues on here. And the range is actually infinite, not the range, the domain. The range is just from +1 to -1. Anyway, hold on now, get carried away. Let's come back. But we know what a function, you put in a value and you get out a value. That's what functions do. And when we go f of x, we're used to this, function goes up, x goes in, and it's f of x. So it's sine of a, and the of, using the of notation. And you should be putting it there because it's a function. But in school maths, we tend to be a little bit lazy about that, and we just write sine of a, and it's okay. Okay, in school maths we can just drop the of, but we want to still say sine of a. We can say sine a, but we can say sine of a, and it's a little bit better to say sine of a. Okay, because it uses the language of function, and it is a function. It's a function that converts an angle into a number. So the sine of a, or a ratio, sine of a equals, now I'm going to leave a space, and we're going to go 0.5216. Now every function has an inverse function. It's as if this is the x-axis and this is the y-axis. We're asking what would come out if we put in, what angle would come out if we get an answer of 0.5216, what angle went in. That's what we're doing when we inverse function. We cross that out and bring it across here and inverse it. So doing that up here now, we're going, here are my sines and cos and tan, and behind it are my inverses. Okay, now so I'm not going to say sine to -1 because it doesn't say anything. I'm going to do the inverse sine, which is itself a function. So we're going to say, instead of when I'm pushing the shift, I'm going to say the word inverse. Inverse sine, inverse cos, etc. So inverse sine 0.5216. It wants us to close off the argument, but let's see if we get away without doing it. Okay, and we get A equals 31.4, checking up here to the nearest degree at 31 degrees. Okay. That's example 1. Okay. So here we are, find the measure of angle A. Well, these are complementary. I'm going to show you something here with complementary in it. So that's the spelling, complementary. Complementary. They're complementary. So you just go 90 minus 36.7. Mental maths or calculator? Calculator? Easier? It's not impossible to do it. Okay, it'll be 53.7. So I'm subtracting from 8. I'm subtracting subtracting from 9 and I'm subtracting from 10.3. Made a mistake there. Use your calculator to evaluate each of the following. So this is a straightforward application of the sine of 48. We'll just take a look here, be a little bit lazy now on this one. Okay, and I'm getting 0.7431. The next one here is the cos of 74. Clear cos degree angle 74 equals 0.2756. The next one is tan of 15. Okay, sure enough, shift equals it if they wanted to give it to me. And where am I now? Tan is 3. So they gave it to me in decimal. That's the exact value. It just happens to be an exact value. I'm not going to start talking more about that. No, wait for your honors maths, leave insert before you want to worry about that. Okay, let's do our shift equals. No, yeah, shift equals. And we're going 0.2679. Good. Okay. And we have sine 72. You get the idea. They're pretty straightforward. 72. And generally you shouldn't ever have to shift equal, but every now and then there'll be a third answer and you'll shift equal if you want to go to digital then. Okay, so 0.9511, great. And cos of 28.5 equals 0.8788. Yeah. Use your now these are inverse sines, but they're really quick, so I'm going to just start doing them up here on the calculator. Okay, so it's inverse. Notice that it's gone into a shift, S for shift here. So it's inverse sine 0.7453. Of course, I'll want you going A equals inverse sine 0.7453, because you just can't risk. First of all, the question might say accept correct answers without supporting work, but it might. They might say with no supporting work dock you something. Okay, and therefore you want this will do you if you want to go straight to that. If you want to do the line above it, you'll do this. I would tell you now though that the chances are that'll be one of these ones that I say lots of students will do it in the calculator, so they probably will accept the thing, but look, it's good practice to write down your maths. It just takes me a bit longer. Okay, so we could basically just say inverse, the bottom one there, inverse cos 0.2154. Inverse cos 0.2154. Quick question. What do you think could happen if I put a number here like 2 or something bigger than 1? Let's check. Inverse cos 2. What do you think is going to happen? There's no answer. Because what cos does, by the way, is it's kind of like a flip version, left to right, of sine. Sine goes up, cos comes down. Cos is a decreasing function. In junior cert, in a right angle triangle, cos is a decreasing function. In a right angle triangle, sine is an increasing function. In a right angle triangle, tan is an increasing function with a bit of a kink, a chicane in it. Okay. You can plot them very easily on Desmos. So I'll say, I think I'll use X, and there you go. We'll do another one, cos of X. We'll zoom in on a second. Okay, and tan x. Whoa. We'll zoom in because we're only interested up to, I like that to be, okay, don't worry about that, that's not saying 90 degrees. There's your 90-degree point here, somewhere here. Just don't worry about that. What matters is cost decreases from 1 down to 0, which that's your 90 degrees just there. Sine increases and tan heads off to infinity. Okay, so it's called an asymptote. Let's switch back over here. Okay, so this is 90 degrees, and there's your, and this is 1. And you can say, hold on, you can't get the cos of naught. Well, not with a right angle triangle, but in the limit it does. So and this comes up and it levels out at 1. Okay, and tan goes on forever this way with degrees here or angle A here. Okay, look, all of them are simple. I'm not going to do them all, it gets a bit boring after a while, but not for me, not for you, because you have to practice. Okay, so here, let's say we're doing this one, you're just bringing the sine across, turning it into inverse sine, shift inverse, 0.2132 equals 12 degrees. So I'll leave the rest of them as an exercise. On we go to question 4. Find the value of A in which, in each of the following, give your answer in degrees. Sure, they're all equally easy, there's nothing new there. I'll skip it. I was trying to roll the mouse to get rid of the sheet of paper. Isn't that funny? Find the measure of the angle. So the only difference here is you're putting in a fraction. We'll just do a few. We lay them out in the same shape as they are there. So the sine comes across to become inverse sines. Inverse sine of 2/3. Did I hit it? No, I didn't, because I'd see an S up there if I did. Now I've hit it. Inverse sine of 2/3. Fraction bar 2/3. I'm going to show you a trick now from yesterday's class about doing a fraction real quick. Okay, we get 41 degrees. Check it here. Question 5, 42 degrees rounded. Okay, so let's do the one underneath it. Inverse tan 6/11. Let's look at the answer first. Inverse tan, question what? 5. 29 degrees according to this, if they're laid out right. Yeah, they are. Okay, inverse tan 6/11. So, okay, shift tan. Now I want 6/11. 6. Oh, it's nearly as slow. I could do 6 divided by 11, of course. But is there any advantage to doing that? First of all, like, okay, count the buttons. 1, 2, 3, 4, call it 5. So no advantage. Okay, we'll keep going the way we're going because it looks good and everything else. Clear. And is there, I'm just looking to see that tan can be bigger than 1. There's nothing, no problems in there. They'll all work out fine for you. Okay. Question 6. So there's no diagram or anything, so that's the first thing we do is a picture. Let's do a picture. Cos of A is this, and A is less than 90 degrees. Find A. Well, shift cos 0.5484 equals 56 degrees, and hence find the value of sine of A. Okay, so basically I'm not going to throw that away. I'm very quickly going to store it to A. Okay, hence find the value, correct to 2 decimal places. So the sine of A equals 0.8, how many places? Oh, this is taking places. 0.84. Question 6. Okay. But there's a trick. Look at this equation here, and I'll tell you why it works. Okay, cos squared plus sine squared equals 1. I'll bring it back here. So we have a hypotenuse. Oh, let's just go with our usual A, B, C. Okay, and let's just take one angle A. So the cos of A equals B over C. The sine of A, now this is higher junior cert, and it's leaving cert as well, but this is the kind of thing that will definitely get your distinction if they go down a rabbit hole questioning you on this. So this is quite an advanced topic, but it's still within the junior cert remit. So we go sine of A equals A over C, because it's just combining trigonometry and a bit of fractions and so on. Now what we want to do now is kind of just go along with me now. What's cos squared A? And this is how you write it. The square of this equals B squared over C squared. The square of this equals A squared over C squared. And when you add them, you get B squared over C squared plus A squared over C squared, and they have a common denominator. They have a common denominator. Okay, which means we can just add them easy peasy, no big deal. P squared plus B squared plus A squared over C squared. And then you go, aha, but B squared, A squared plus B squared is C squared through Pythagoras. So that's C squared over C squared, and that's 1. So what's all that about then? Well, they asked us a question back here. They said, we know what cos is, find sine. So what we could have said is, well, we know cos squared, and don't worry about this A here. I'll just write cos squared plus sine squared equals 1. Okay, so we know that, let's arrange it so sine squared is on its own by transposing the cos squared. And then take the square root and you're done. Now after all that, so what I'm saying is 1 minus 0.5484 to be squared, take the root, will give me the same answer as this 0.84. Check it. So if you want to get a sine from a cos, you go square root. Now it's advanced, don't worry about this, it's going over your head or anything, just skip it. Minus 0.5484 squared. Now, did I get it right? Is that going to come out to be 0.84? Actually, I doubt it is. Might have made a mistake. That's the sine of A. Let's check. Boom. Yes, it is. Okay. That's just another way of doing it. That was question 6. We're on to question 7. If tan is this, find tan of it. Find A in degrees. So that's straightforward. That is just a straightforward application of shift tan. I was turning it on and off. I didn't know that that happens. Look, on. Here. Oh, it's getting slow. Off, on again. Okay, when I click it, it seems to get on again. Oh, sorry. Okay, inverse tan 1.3462. Go for it. Correct places of decimal, 0.39, 53.39 degrees, 3.4. Did they not say 2 places of decimals? They did. Mistake there. They said 2 places. Write down each trigonometric ratio. Let's go. Write down which trigonometric is needed to calculate the angle up. Okay, no. Let's go. Where do they meet? They meet in the complementary angle, or else you can go 7. Yeah, so it's sine. Where do they meet? It's tan. Where do they meet? They meet at the reference angle. It's cos. Find correct to the nearest degree the sizes of the angles marked A, B, and C. Okay, so what we're going to do here is look at where they meet. Okay, it's the complementary, so we'll write down the sine of A equals 6/10. It could reduce, but sure, what's the point? You've got a calculator here. So we'll bring the sine across. If you're because you have to write so little, you'll be writing this in the exam, inverse sine. I'm just not going to write it every time. I think I've explained myself long enough now. Shift sine 6/10 equals. Okay, write it down. We'll drive on. 36. You can see it here, of course, yeah, but it's basic enough. 37 degrees. Okay, on we go. Now here's the important thing. Which is it? That's the important thing. Anyone can do inverse sine, cos, and tan. Okay, that and that meet here at the reference angle. Their included angle is the reference angle. Up here, the included angle. Get to know your language, use it in an exam. The included angle is the complementary angle. The complementary angle. And if the included angle is the complementary angle, we are using sine. Okay, let's go with the trig. Can you see me here? You can. Trig function. Let's make a table. Let's be systematic about this. Let's go bigger. Okay, let's go and systematically summarize what we know. What's our trig function? Sine, cos, or tan. And what's our included angle called? And we really need the sheet from the tables. I know I have it on PDF, but every time I go up there to PDF, I forget to come back down again. Don't I? It's causing great trouble. So the way we want to go here is like this. And say, now you would also be going quicker than this. You'd say sine. You may not need this, in other words. You should be going, I know the connection is sine complementary angle. Cos is the reference angle, the one with the letter. And in case of tan, the included angle is the right angle. And that's exactly what we're learning from this. If you've A and B, so think of it this way, start here. If you've A and B, look where they meet here, and you're being told then that the right angle tells you to use tan. If you've B and C, they meet at the reference angle, and so the reference angle tells you to use cos. And if you've A and C at the complementary angle, the complementary angle is connected with sine. See? So we were just, I didn't finish them out, and I just managed to find some space here. So I'm going to go with, it's definitely, so straight away when I look at that, I go really quick. Cos, they meet here. Sine, they meet here. So it's really quick. Shift cos 3/8. 60 whatever degrees. Shift tan 4/5. 38 degrees. That was question 9. 59 degrees rounded. Okay, and on we go. What have we? 2 more questions to go. 10. In the given triangle, all of the lengths are in centimeters. Calculate the value of each angle. Very easy. They meet here. It's tan A. Now this is one where I wouldn't be skipping this. They meet here. It's tan A equals 6/15. Bring your tan in there. Left meant to leave a space. Inverse tan 6/15. I won't make the same mistake next time. They meet here, so it's cos. They meet at they meet at the reference angle, so it's cos. I did it again. 5/12. That's not there. That's, I don't know, rubber and pencil. Anyway, cos goes here. Cross it out here and inverse cos it here. I'll do all the calculations in a second. And they meet here at the complementary angle, therefore it's sine. Now this time I won't make that mistake. The sine of C equals space 7/14, cross it out, inverse sine. And that's lovely in the exam if you want. Work your way down if you want as well. And especially if you're making my little mistake and you're forgetting to leave that space. Clear shift tan 6/15, 21.8. Shift cos, is it a shift cos? It isn't, so that'll happen. You make that mistake, go back again. Shift, there's the S, cos 5/12, 65.37 truncated. Clear shift sine, anyway, shift sine 0.5. See that? Speed things up. 7/14 is 0.5 equals 30 degrees. Okay, and we're looking at them here. 22, yeah, 65, yeah, 30, yeah, to the nearest degree. That's what they did. And last one. By using the appropriate ratio. Now I want to slow down and make sure, give you a second. Look at the 2 sides we're given, and can you see where they meet? Those 2 sides, what vertex, what corner do they meet in? Okay, where does this meet this? They meet here. And now let me put a C for complementary. They meet in the complementary. You write down the sine of A equals, if you leave a space, the sine of A equals 4.2. It can write 42. Why should I bother with the decimal on the calculator? Over 63. Okay. You see that trick? Do you agree with it? Shift sine fraction. I could have done quicker than that. Shift sine 42, inverse sine 42 over 63 equals, now to 1 decimal place, 41.8. So So maybe when it's on your calculator is the time to look back up here and see what they're looking at. What level of accuracy? You write it down. What level of accuracy? You should do what I'm doing when you're watching these videos. You should write down. You should have out your paper and write it down. I put these up on YouTube as well. These PDFs in case you have a printer at home and that. But I wouldn't. You know, you can just be working in a copy. What level of accuracy is required? You can do that when you're here at the calculator stage and about to take it down, just to speed things along for us. So anyway, we have this meeting this at the right angle. That's tan. When they meet at the complementary, it's sine. When they meet at the right, when the included angle is when they meet, so it's included angle at the right angle, it's tan. And when they meet at the reference angle, the one with the letter, it is cosine. So just quickly to scribble down says, I know what I'm doing here. Hold on a second, yeah, and this one is sine. Okay, so we're going in here, it's tan. Then you have to go through the motions of the ratio. You have to go and find your top and your bottom. Come across decimals, let's multiply by 10 for both. And then b equals inverse tan 51 over 64. You know this thing about leaving the space? I think maybe for you, so you're learning, it's better to do this because you're embedding it better. Okay, and then here again we're going the cos of c equals never go to the hypotenuse first, go to the adjacent. We'll scale up by a factor of 10 to speed things up. Okay, and we'll do c equals inverse cos 91 over 109, and we'll scoot across here and all the time going to one decimal place, shift inverse tan 51 fraction bar 64 equals, now forgot to do inverse tan, and luckily we got a bit of a sting, got a bit of a surprise. Okay, because I'm getting the tan of a tiny, and the tan goes like this, so I'm getting a tan of a tiny value, I'm getting a small value out, but that alerted me to my mistake. Can I get back here and inverse tan it without having to do up my fraction again? I can by that, shift tan, yep, like it. 38.5, 38.6, and degrees, that could be 1 mark lost, that could be an F star. Okay, clear, shift cos inverse cos 91 over 109 equals 33.4 degrees. 41.8, 38.6, 33.4. We're done. Are we done? Nope. I like it. Okay, a bit of algebra first. Isolate the sine of the angle. Okay, so let's write it out again and let's solve. So actually we're solving, like, this is just algebra. The whole thing is algebra, but so we're solving for theta. So we'll dress this up in the language of algebra. The whole thing is algebra. Divide by 2, and it's just apply mathematical algebraic operations until theta is isolated. So what's the overall strategy is but it always has been, even what we've been doing, everything now is to isolate the variable that you're trying to solve for. Okay, so to isolate the variable, you first isolate the function of the variable by dividing out the 2. Okay, and now we isolate the variable further by inversing the sine function, or applying an inverse sine to both sides. It has been applied here, that's why it's gone away, because you see, inverse sine of anything is the anything, so that's why the theta is there. And then the inverse sine of a half is one we're going to see in the next, is a special one where we don't have to go to the calculator. You can, but it'll be 30 degrees. Okay, so we're just isolating the variable. It'll go line, next line down is this. So this is an equivalent equation, meaning it has the same solution. This is an equivalent equation. This is the solution, needs to be calculated. (66 degrees to the nearest degree), 66, 30, 66. Inverse tan of a half, nothing special there. So I can, I look at this now and we go, okay, we're in a hurry. The exam about to end. Tan inverse a half. And what's quicker than tan inverse a half on your calculator? Tan inverse 0.5. Boom. 26.6 degrees. To the nearest degree, 27 degrees. Hey! I'm not on the last one, am I? Question 12. What's up here? Okay. 30, 66, 27. The last question. And guys, I think it's good to make a whole video for a section. And you must agree too, it's all about the exercises, learning through problem solving. Okay, here we go. So looking at the diagram first, always look at the diagram first. My assumption is they're going to say there's a right angle here. I have a 12 and a 30, and I'm finding the angle. Now where does the 12 meet the 30? Well, it's obvious, it meets at the right angle, so it's tan. The tan, I wouldn't even read that now. Tan of x equals 12 over 30. Don't ever reduce your fraction, because there's no point you're going to the calculator to do all that anyway when it's doing a much more important thing. So x equals inverse tan 12 over 30. Absolutely no point in reducing that fraction at first. (21.8) to the nearest degree, 29. 22, I mean, the nearest degree is 22, and that's it there. Okay, great session. As always, go upside down, and I had the human touch. See you in the next one.